Good afternoon. My name is Mr. Richard Chrysler, and this afternoon we're going to talk about your last experiment in the Process Control Lab for the 600 series experiments, temperature control. And so whether you're assigned to experiment 610 or 620, you're going to use a temperature control apparatus, the gun temperature control apparatus. So that's 620, this 610 over there, but you'll also use the water heated temperature control experiment that uses the I-Series controller. And one of the things I wanted to show you about this, and you can look at the Process Dynamics video, the 600 series, and get some more information about these systems and how they work. But this time, for this video, what I want to focus on is an element of this experiment that was not present before, which is the data collection. So I have set up a macro that will get data from the controller and bring it into Excel, but there's some important points you need to understand about how this works. So first thing is, let's say that, and this is going to be an important point. For this particular part of the experiment, you will use your own controller file that you will configure when you do your pre-lab worksheet. You'll use that. You'll send me that controller file, and I will install that controller file on the controller. So when you come in, that plus whatever flow rate and any other initial conditions that you want, I will have that all set up for you. So when you come in to do your experiment, it'll be all ready to go for you. So the system is now at a steady state, and so when I first come in, I want to start data collection. So this program, this spreadsheet, is on the desktop. It's this PCLDAQ 600 here, and it should be open already. So you fill out the important information here at the top, because you don't want to start typing in any of the cells while the macro is running. That's going to be very important. And to start data collection, all you have to do is press Control B, and it will activate a software wedge program that will then go and get the data from the controller and bring it into Excel. So here I am. I can watch the data in real time because it will display it here with using a graph. If I induce and put a disturbance in there to evaluate the performance of the system based on a disturbance, I don't have to pause data collection. And so when I make the change to my system, the system is going to respond based on the PI and D parameters that I programmed into the controller. And while I have a disturbance, I don't need to pause the data collection. And then you can let this run to reach, or you should let this run, and if you have programmed the controller properly, it should get back to your set point, which originally I have set for 30 degrees Celsius. Now, I could let this wait, or let this run. I should let this run to reach a steady state. But what I'm going to do now is I'm going to show you another part of what you're going to have to do with the software and with the controller, which is going to be very important, and that is changing the set point. Whenever you change the set point for the controller, you don't want to do it using the configuration program on the desktop. You want to do it from the front panel, and I'm going to show you how to do that. But before I do, one important thing I'm going to have to do is pause the data collection. So as long as you see this cursor changing from a cross to a hourglass, that means it's collecting data. And to pause it, I press Control P. And once I press Control P, the cursor should be solid and it has paused data collection. Now I can safely go in and change my set point from the front panel. And so to do that, I'm going to press this key here, and it says set point 1. I don't want set point 1, I want set point 2. Okay, because this controller is configured to output 2, and so I have to change set point 2 in order to make the change. So I then press enter, and I want to set this, let's say I want to set this to 40. You got to be careful because the buttons are very sensitive and you can easily overshoot. So now here's another important part. I want to restart data collection as soon as possible after I input this new set point, because as soon as I input the set point, the system's going to start to respond, and I want to catch as much of that initial change as I possibly can. So to do that, I press and hold the control button